Hello, grade 10. So let's continue on with the next part of the starter. This question is tricky a little bit. Okay, so let's take a look. So we've got 59 here, we've got 34 here, and they're asking us for angle BCD, this whole one. Okay. Can you see the parallel lines here? This is a good clue. Always try to use the information that they give you. Perhaps you remember you did this in bearings and also in previous grades, hopefully. But when you have the C pattern, in this case the C has been turned, but no matter, that when you have the C, that the angles are formally called co-interior, and therefore they add up to 180 degrees. So since this, so that means that this and this angle will make a total of 180. So go ahead and type in 59 plus 34, and then subtract that from 180, and you will get this to be 87 degrees. Okay. Moving on to the next part. All right, now they're asking us for BXC. Oof, not easy. All right, so what can we do? And I was stumped for a little bit here myself. This is not the center, okay? Don't make assumptions. This is very important with these circle theorems. If they don't tell you that this is the diameter, then it's not. And if they don't tell you this is the center of a circle, then it's probably not, even if it looks like it. So we're gonna have to take out some other tools. Well, do you remember the theorem about the angles on the same arc and how those will be the same? So we can actually do that here. If you look this way, and these are held, right? Make sure they're held by the same points. So actually, if you needed to, you could label this 34. And again, you're not doing this because it looks the same, but because you know this theorem. Now, how is that useful to us here? Well, we're trying to get to that angle in the middle with the x. Well, if you just turn your head a little bit, can you see that the angles that are created by the lines A and D are also going to be the same? So this is actually 59. That's an ugly 5. Okay, this is 59. We found out the whole thing is 57. We can subtract 87 minus 59. That's going to be 28 degrees. We're not done yet, but we can now finish. So now we can just look at this triangle BXC, and we can just determine 180 minus 34 plus 28. So the other two, and you can see that this will kind of be a big angle. Type it in with me, and you're gonna get 118 degrees. Okay. The last bit. So here they're asking us for angle ADB. All right, let's choose another color. Let's be blue. ADB. So they're asking us for this one right here. We're going to use the same theorem about the angles being the same on the same arc if they're held by the same points. So if you picture turning your head 180 degrees, or you can just turn the circle around rather than your head, I guess that's easier. We found that this was 28, and so therefore this is also going to be 28. Woohoo! Okay, so the next bit, this is cut off a little bit, but no matter. Let's try to get through the next question. Okay, so we've got a tangent here, and it touches O. The chord is parallel, and AOT is 52. I've started us off here just a bit because this is one of those tricky situations that I mentioned in the podcast, that people look at this and then they go, huh? What is this? But if you think about dragging this point up here, can you see how what you end up with is the Star Trek theorem? Do you remember that in the Star Trek theorem? Let us remind you, be careful, this has to be the center, that this is always twice whatever it is here, which means that this is 52, this is going to be 26, and now our theorem about the same angles on the same arc, then this ABT is also going to be 26. Excellent. Okay, next one. we're asked to find angle OTB. OTB. Okay, so this one right here. What can we do? Again, oh, look at this, parallel lines. Okay, so first of all, do you remember the Z pattern? We can use the Z, and in a Z, who remembers the fancy word? Alternating. Maybe you said alternating, or maybe you're sitting there saying, I have no idea. Leave me alone, woman. Okay, anyway. So this right here is 26. But we need this inside one. So now we're going to need our handy dandy radius tangent theorem. That's why listening to all those podcasts was really important. Do you remember how any tangent meeting the radius will always do so at 90 degrees? So now this is 90. The outside bit is 26. And therefore, our inside bit will be 90 minus 26 will be 64. So if you got 64, then give yourself a smiley face and consider yourself awesome. That's it.